Okay, this is from problem set 1, and it's covering solving equations with 0, 1, or infinitely many solutions. And you've got 2 equations to do. I've copied the first equation over here. Whenever you solve an equation, you have to remember that what you do to one side, you can do whatever you want as long as you do it to the other side. However, before you start, doing stuff to both sides, you want to try to simplify your equation as much as possible. And I have a set of parentheses here. So I'm going to use the distributive property to clear out the parentheses. So I'm going to take this -4, multiply it times that u, and that's going to give me a -4u. But I'm also going to take that -4 and multiply it times this +3, because technically I'm done with the u. So it's like taking a -4 times a +3. A negative times a positive changes this plus sign here to a minus sign, and 4 times 3 is 12. Now, the parentheses end there, so that's where the distributing ends. So when I get to this -3u, I'm just going to use my copying skills. I'm going to copy it down. I'll copy down the equal sign. Then I'm going to come over to the other side of the equal sign, and there's a second set of parentheses. So I'm going to distribute the 2 to clear that set out. And 2 times u is a 2u. And 2 times a 3, a +3, is still a positive, so that plus sign doesn't change, 6. Okay, so I got rid of parentheses. Now I have to look at either side and say, is there anything else I can do to simplify this up a little bit? Now on the right side, 2u plus 6, those are not like terms. I could only add 2u to 6u, or a 2 to a 6. Because this one has a u and that one doesn't, it's just going to stay as a 2u plus 6. But over on the other side, I've got a -4u right here and a -3u over there. Now this -12 that's in between doesn't have a u, so I just kind of ignore it. And I'm like, if I got -4u's over here and -3u's over there, how many u's do I have? Well, -4 and -3 adds up to -7 u's. And then I still have this -12. This 12 didn't go anywhere. All right, that is all the simplifying I can do. Now I have to start using the what you do to one side of an equation, you have to do to the other. And before I start using that, I'm gonna just recopy this all down in one color. Because sometimes if I start using too many colors, it just starts to look too much like a rainbow and we don't know what's going on. Okay, so both sides of the equation have 2 terms, and they both have a term with a variable and a term without a variable. Your job is to get all the terms with the variables on one side and all the terms without variables on the other. And it really doesn't matter which side you get them on. That's a personal choice. Some people always want their variable, their letter over here on the left, so that when they're done, it says, x equals a number, or in this case, u equals a number. So, other people are like, I'd rather have my variable a positive variable. So they might get rid of the smaller u. It really doesn't matter. I'll probably just go ahead and get it on the left because a lot of people do like to do that. So that means I want all the u's on the left, which means I don't want any u's on the right. So since this is a 2u, which is really a positive 2u, what I'm going to do is I'm going to subtract a 2u from it, because 2u take away 2u is no u's at all. Gone. But since I put this in on the right side, I also have to put it in on the left side. Okay? You have to keep it balanced. It's kind of like a scale. If you've got 10 pounds on the left side and 10 pounds on the right side on a scale, it balances out. But if I were to take 2 pounds off this side, then all of a sudden my scale goes like this. In order to bring it back into balance, I'll have to take 2 pounds off this side and bloop. Now they're both 8 pounds, but it's still equal. So that's the whole idea about what you do to one side, you got to do to the other. You've got to keep the balance. You got to keep the equality. So now negative 7u and negative 2u would be negative 9u altogether. I still have that minus 12. I still have the equal sign. Those canceled. So now all I have over here is a 6. All right. Now I have to start focusing on what is u. Well, I want u by itself. I want to do some more math so that when I'm finally done down here, I got u on the left, I got an equal sign in the middle, and I have a number on the right. So to get this u by itself, the next thing I'm going to do is get rid of this minus 12. So I'm going to add 12. Just like I got rid of the u on this side, I'm going to get rid of what I like to call the non-u, the non-variable guy on the left side. So I'm going to add 12, so that cancels out. But if I add 12 over here, I got to add 12 over there. So now I'm going to have negative 9u on the left, and 6 and 12 is 18 on the right. And now I just have one step left. I'm going to take this negative 9u, which technically means negative 9 times u. And the opposite of multiplying by negative 9 would be dividing by negative 9. So I am going to divide both sides by negative 9. Now over here, a negative 9 divided by a negative 9 technically makes this a 1 u, but 1 times u is just u. And then over here, 18 divided by negative 9 is a negative 2. So this is an example where solving equations with 0, 1, I got one answer. U equals negative 2. So I'm going to come up here, click on this box in Alex, and type in a negative 2. But then I got this second equation here. All right, so I'm gonna have to solve this one also, and to save time, I'm not gonna recopy it. I've got a set of parentheses here. I'm gonna distribute the 2, just like I distributed over here. 2 times w is 2w, and 2 times 2 is 4. You do not distribute the 2 to this w because he is not inside the parentheses. So I just copy him down, plus w, equals, on the other side of the equal sign, I have another set of parentheses. So I'm going to distribute the 3 over here. That's going to be 3 times w is 3w, and 3 times 1, or minus 1, is a minus 3. And same thing, this 6 is not inside the parentheses, so don't take 3 times 6. Just use your copying skills and copy down plus 6. Okay, so now I want to look for anything I can simplify. And remember, the equal sign separates the left side from the right. So you look at them separately and you're like, what can I do over here? Is there anything I can do to make this simplified? Sure. You've got this 2w here and a 1w there. That adds up to 3w's. Remember, there's really like an invisible one right here. So that's 3w's all together. And then you still have a plus 4. All right, there was no w on him. Over here, I've got this green 3w, but there's no other w's to combine. So that's just 3w. But I have a negative 3 and a positive 6. I can add those up. That's going to be a positive 3. All right. Now, at this point, I have a 3w plus 4 equals a 3w plus 3. I want to get all my W's on one side and all my non-W's on the other. So the next thing I am going to do is subtract 3W. Just like over here, I subtracted my 2U to cancel out the U on the right. I'm going to cancel out the W on the right. That cancels out. But what happens on this one is when I go to subtract 3W on the left, uh-oh, that cancels out also. Now we have a dilemma. I'm left with this 4 on the left. There's my equal sign. And I'm left with this 3 on the right here. And that's a problem, because you know what? 4 does not equal 3. What does that mean? Well, I'll tell you. When the variables cancel out and what you're left with does not equal, what that means is there is no solution to this problem. There's absolutely no number in the world when you stick it into all of these W's here and then do the math over here and get a number, and then do the math over here and get a number, you'll never get the same number. They'll never check. It'll never actually complete the equality. So this one's a no solution. Okay, so the first one gave me an actual answer. This one gave me a no solution. But there's a third choice here for an option on the multiple choice. It's all real numbers or solutions. And you're probably wondering, well, when do you have that? Well, it's simple. It would be just like this one where the W's cancel out, except what you'll be left with will be equal to each other. When the variables cancel out, if the two numbers are not equal to each other, that's no solution. But let's say the 3 W's had canceled out, and what I was left with was, let's say it was 4 equals 4. That's a true statement. This is a true statement. Which means in this case, you would say all real numbers. I've seen some textbooks also say infinite solutions, but Alex is saying all real numbers or solutions. So that just simply means that I could pick any number in the world and plug it back into the original equation. And when I do the math on both sides, I'd end up with the same number. Like let's say W came out to be, I don't know, a 5. If I plugged the 5 in here and the 5 in here and did the math, you know, I might get, I don't know, 22 or something. Which means if I plugged it in over here, I should also get a 22. Now 22 is not the answer. They're just saying that the number that you, well, for example, over here, I got a -2. If I plug -2 into the original equation, let's see, -2 plus 3 is 1, times -4 is -4, and then -3 times -2 is a +6. So -4 plus 6, that's a 2. When I stick it in over here, -2 plus 3 is 1, and 2 times 1 is 2. I got 2 on both sides, which means absolutely nothing. It just means that it's balanced. When you stick in a -2 where the U's are, you'll get a 2 over here and you'll get a 2 over there, which simply says, hey, your answer checked. You found the number that actually causes the equality to happen. So I hope that explains all that. Have fun.